Hello everyone, in today's video we'll go through upgradable contracts. Here we are on Openzeppelin Wizard Tool. We are here because in this tool you can get a simple version of basic contracts, but we'll go for the upgrades today. So to do that, first we'll set the token name and symbol for the Twitter. You can name it as you want, and we will permit some of tokens because in the future we want to show you that the minted amount will change because we will mint some other things by the upgradable. So for the features, we'll choose burnable, pausable, permit and votes to have a lot of function which from we can choose and work on. Also, we'll set access control as the roles because we'll be granting the role of the minter to further mint some of the tokens. Also, 100% choice is upgradability for the transparent because it's the simplest one. And we'll go through that in the moment. Now we can just copy everything if it's corrupt, copy to clipboard, and we can go to Visual Studio Code, but we don't need to paste it because it's already in here, because we've prepared some basic template for you. Okay, Jacob, if you could add something about that.
Yeah, so we have the same exact code here, and it's a simple transparent proxy, which means that at first we'll have to deploy a proxy and the first implementation, and then when we decide to add new functionalities, we'll use a second version of the implementation, a new one, and deploy it, change the implementation address in our proxy, and test if everything works properly. Yeah, as you can see, it looks a bit different than normal contracts. We are using contracts upgradable. Simple Openzeppelin contracts wouldn't work here, not only because they use normal regular constructors instead of initialize functions, but there are also some other reasons. But if you want to learn all the theory, we will link useful videos and articles in the description. So if you want, you can spend time on that.
Also about the whole setup, we'll leave the link to our GitHub repository.
Yeah.
If you want to access every library we'll be using, there will be in the README, so don't worry about it for now, okay?
Okay, so we have a real life contract. So now it's time to deploy the proxy and the first implementation. To do this, we use scripts because our environment is hard hat. And here is the first script. We are using upgrades and eathers from the hard hat module. We use verify utility function custom created. We'll show you later. And we are using upgrade score module here to get the implementation address of the proxy. But first we start with, as usual, getting the contract. Then, a bit different, we use upgrades module here to deploy the proxy. And we deploy proxy on top of the given contract, so our breather contract. Then when the proxy is deployed, we log the address, and we'll use the address to get the implementation address. So basically our breather contract. And so to do that, use upgrade score with this function, and then we log out the implementation address. We use console logs to make it simple to find this later on the RunKB scan. And last thing we do is verify function, which is stored in the mentioned utils file. And what it does, it takes address of the contract we want to verify. So first implementation, then proxy, and then tries to verify the contract using the Hardhat plugin, the run function. If something bad happens, it's catched, and you have the reason in your terminal. And if everything's alright, no logs here, and we print out done, and the function is done. So now we can run this. To do that, we need to write npx hardhat run, provide the location, which is this, and specify a network. And we use ringkb. So if you don't have ringkb, you can use any other Ethereum testnet network, but for this tutorial we use this one. So let's run it. Okay, so it's all right. The proxy was deployed. We have the address, implementation 2, and both should be verified.
Yes, and like that, we need to go for the Etherscan. So now let's get the address of the proxy. And here we are on ringkb Etherscan. So let's paste that and search for the contract. Okay, let's go for the contract tab. And here at first we can check if we can read the contract for now. And we can see that we cannot. So how to do that it will be working. So let's go back to the code and get more options a little below. And let's check, is this a proxy? Okay, let's verify that. It's our address. Great, and we have to save that to begin verification. Okay, let's head back. Let's reload. Okay, now we can read it as a proxy. So if we go to the tab, we will see our readable functions. Also, we can write as proxy, so we can access some of our functions, create or do something. And it will be the same step every time. So now we can go back for the Visual Studio because we want to make implementation. And Jacob, if you could proceed.
So now we want to introduce a new feature, which is minting more tokens. So we create a new contract, which is version 2. We extend the original one. And now we introduce the minter role, bytecode, so that we can grant it to some users, some addresses. And we introduce a public mint function, where we use the role control feature we selected in Openzeppelin Wizard, and we use this to trigger the internal mint function.
Honestly, we would like to change a little that function, right?
Yeah, so we want to break things a little bit here to be able to later go and fix and see if we provide a v3 version which fixes all of the issues here and if it all works. So we change it a little bit and make it mint tokens, but not to the specified person, instead to the contract we are in.
So address this, right?
Oh yeah, mistake. So yeah, now we have the version 2 ready and we can upgrade it. So we go to the second script, and here it's really similar. We have the same dependencies, but the first thing we have to change is the proxy address. So we just copy the one deployed minutes ago, and also we use the version 2 contract, And here, instead of deploying proxy, we use upgrade proxy, because we don't want to create a second proxy. We just want to create a new implementation and connect it to our already existing proxy. So we provide the address, we provide the new implementation, and when it's deployed, we log everything out, and we verify, but verify only the implementation contract, not the proxy. Proxy is already verified. So let's run this script on the same network.
It's already calling that there's an unused parameter, but we did it on purpose to change it in the future. So don't worry about that.
Yeah. Okay, so it's updated, and we can go back to our proxy and see what happens there.
Yeah, so let's go to the Etherscan. And let's refresh. And we can check if anything is being added.
Yeah, the minting role hasn't appeared, and that's because sometimes it happens. The automatic verification failed, and it says so, that the current implementation is this, but it's not verified. So we need to do this manually, and for that we'll use hardhat plugin and say hardhat verify network ring B and the address. So as you can see, it's the implementation address that fails to verify. Sometimes it happens. Okay, let's try again.
Yeah, now we can access meter role. So our main goal was to mint some of the tokens. Now to do that, we can write as a proxy. So we'll get, as Jacob just did, the bytes for the meter role. Because we want first to grant ourselves the role of the minter. That was the point of access control.
Yeah, so I'll switch my account to one I want to be the minter, and copy the address and provide the minter role for the set account. And first I need to click on the connect to Web3. It's a beta feature, so it doesn't always work properly, but usually it does. And while it's all processing, we can continue with the mint function. It went through, and let's say I want to mint some tokens for my other account. I'm going back to the one with the writes because the feature here is pretty buggy. And now we need to provide the amount, so using converter. It lets us mint 10 more tokens. And shortly we'll be able to see, when you go to the tracker section, how the holders page changes. So we have 10,000 tokens, initial 10,000, and 10 more on top of that. Still processing in the holders section. But yeah, after a minute we can see that another account has 10 tokens we just minted. So our upgrade is successful and everything seems to be right.
Yeah, for that video that will be all. But in the next video we are going to fix the changes we've made with the meeting function by making another implementation and also solving another things. For now, I think that would be everything. Thank you guys for watching. Leave a like, subscription, leave a comment. If you have any problem, we would gladly help you. And see you.
Yeah, see you next time.